So today let us start our discussion on synchronous motor. We will first take synchronous motor, cylindrical rotor, and then we will take the like salient pole machine. But before I start, I would like to say that instead of following any conventional book which may consume a hell lot of time while we are running short of time, and in my opinion those means spending those times on those topics may not be means good decision or and wise, like that the way we'll spend that time may not be the good one. So what I would like to do here is that just try to understand the basic operation of our synchronous machine in light of synchronous motor, in light of DC machine and synchronous generator, how we can means DC motor and synchronous generator, and how we can mix these two, means can extend the understanding of these two theories to understand synchronous motor operation. First of all, try to understand that I talked about counter torque. So what is that counter torque? It is the very torque that opposes the means flow of current, sorry, the very cause of your generator operation. So what is the very cause of your generator operation? It is the torque applied by your prime mover on your generator shaft. If you can somehow slow down or retard the prime mover shaft, you will be able to reduce the amount of induced EMF. So what happens in generator when a current flows through generator? It actually tries to means it tends to slow down the machine. This torque is produced by our armature reaction of our armature current and our armature current and your means field flux. These two act together to means, and they try to slow your machine. How? Let us try to understand. In cylindrical rotor, what you have? You have, let me draw a very rough freehand diagram. Okay, just a minute, let me draw it. So now it is the diagram I have drawn, and you can see here that it is like what is happening here for a motor, sorry, for a generator. Instead of means deriving equations, let us first try to understand that what is happening here. In case of generator, your field is like means what you are having here is leading, right? And that one is like means, let us assume that we are having like pure resistive load is connected with armature circuit, and therefore the armature current is in phase with the induced voltage. So this will be the reflection of like dot and cross will be there, because your armature actually means, don't get confused if you compare it with the books. then you may first of all you may find a different result, but I think this diagram is correct uh, because first of all I have verified it using Fleming's right hand rule. Another thing here is that is quite interesting, is uh, we are having here, means if you compare it with the book, then you may get means apparently it may contradict with the picture given in the book, but try to understand that in every book it is mentioned about armature rotation, but here I have considered that field is rotating, right? So if field is rotating, means field rotation in clockwise direction is indicates that armature rotation in counterclockwise direction, like they are relative. So means if that is the case, then you can get this kind of things here. Now see that what is happening here. For this you are having this kind of N and S. Now let me explain the genesis of this counter torque. So for this you will have your means let us consider that we are having here. So this one is producing our maximum means field, and that is in this direction. Now for others it is means we have already proved that this means rotating magnet will be 3 by 2 FM. Now see the polarity. Here this one is creating N, this one is trying to rotate in this direction. So this N will always try to repel this person, means your rotor, in reverse direction. So that is the genesis of our counter torque. Now if you look for a formula that is suitable for our means counter torque generation, then obviously we can give you this formula, that is just a minute. One minute. For an armature current flowing through we can find out the average torque can be given by this formula. Actually this comprises the number of turns. That is our armature current. L is the axial length of armature, R is the radius of the armature. This L is means excluding that overhang region, and cos theta. So this makes it very clear that when you are actually applying pure reactive load with either leading or lagging, then your torque will become zero. And we have already established it in another way, that do remember this counter torque is directly proportional to amount of the quadrature component. No torque can be generated if these are means in line with your means in that case it will become just like a transformer, either means demagnetizing or magnetizing. There will be no such kind of cross magnetizing things will take place, right? So for cross magnetizing you need in phase current flowing through your armature winding. I have already explained it in detail in my fundamental of rotating machine video. If you are not clear, please go there and watch it. Otherwise, this will become means burden on yourself. Or else, what you may totally discard this physical understanding and try to mark it up if you are finding it too difficult to comprehend. But that is not desirable. Now, move on to our next part. If you try to figure out this B, you will see that your B will be, this Bm can be written as, the working flux can be written as B average LR, and that will become if you consider that it's a sinusoidal distribution, so it will be so what is the point that P phi is equal to, or rather P phi is flux per pole, so what you can do here in this expression, you can put this and eventually you will get something like, okay, this one is for single phase, for three phase it should be 3 times, so here you should get 3 by 2, and this one will become 3 by 2 P phi Z I m by 4 cos theta. This is the amount of counter torque. Clearly for theta is equal to 90 degree, your torque will become 0. Right. Counter torque becomes 0. Now, so I hope you understand the means genesis of counter torque, and this is the amount of torque which is going to act on your rotor. So it will try to slow down your rotor, so it can reduce the rate of change of this. And now we must try to understand the genesis of means motor torque. But before I discuss, let us quickly revise the direction of power flow from generator. In case of generator, what you are having here means I am not considering the field input, I am considering only the mechanical input that is given through a prime mover. Then that mechanical input, now think about it, that who is responsible for supplying your core loss? Isn't it the mechanical input? If you see my previous video, then you will find that only field copper loss is being carried out, or means is being supplied by our DC voltage source that is connected with field winding. It is not going to supply anything. anything it is not going to supply. It can only supply the that this field ohmic loss. Other than that, core loss, it need to be supplied by this one mechanical input. Then what is there? Then what you will get here is your electrical output. Now let us draw the phasor diagram of a generator. Let me draw it very quickly, a freehand diagram. So what is happening here? That is very thing. One thing make it very clear that this one is the varicose, and that is why it is, or in other way, FR is the varicose. That is why it is leading this one, your E. Right. Now this is the case of generator. I am discussing only cylindrical rotor, salient pole rotor we will discuss later. Now if we cause a reversal of current, okay, for generator let me write down the equations in terms of the power flow diagram which I just drawn in this here. It is something this is the power equation. In case of motor, what will happen? In case of generator, your current is flowing outward. Means from generator it flows to your load. Means power is flowing outward direction. Now in case of motor, what will happen? The power will flow inward direction. So inward direction power can means we can now conclude that electrical input V is cause of flowing current through the means armature circuit, and that is going to produce torque. Actually, what is happening here, think about it, that here you are having this, and your this NS, it is actually experiencing kind of, means this current, it is causing a flow of power outward your in outward direction, like this one. If this is your generator, here the power flow is in outward direction. Now in case of motor, what would happen? In case of motor, the power will flow inward direction, right? The power will flow in inward direction. Now if there is an inward flow of power, what will happen? The inward flow of power will make it like, okay, if you are having trouble in visualizing that, let us come to this equation. Here, what is this cos theta? This cos theta is responsible for your counter torque. As I have discussed that for purely reactive load, we are getting cos theta is equal to 0. That means counter torque is becoming 0. Now, how we can make this counter torque negative? Now, negative counter torque, mathematically negative counter torque, physically you can interpret that one as some torque that is assisting your prime mover rotation, or it is actually pulling your prime mover. Means it is going to assist your prime mover rotation, and it may happen that if you have if you can generate a stronger pull, then even if you withdraw the mechanical power that you are providing to your prime through your prime mover, the electromagnetic pull may be so strong that it can means continue, or means it can allow your rotor to continue at a synchronous speed. Now the biggest question here is that how we can realize theta. Means what I am trying to say, that with any electrical load, your theta is within this range, like means, and for this you can understand that it is impossible to generate cos theta that is negative. So you must go beyond this range. So how can you step beyond this range? Once you change the direction of current, like instead of providing a generator, now see, just let me show you, if we change the direction of current, then what would happen? then this will cause Sn here, isn't so? But see, this is now rotating in this direction. Obviously, from R to Y, then to B, it will rotate in this way. So, if that is the case, then can't we conclude that now previously it was trying to repel your rotor, and now it is pulling your rotor, and if this pull is sufficiently large, then it can actually ensure synchronous rotation of your rotor. Now, now it is clear that we need to allow flow of current in reverse direction. So, if current need to be reversed, then what let us based on that synchronous impedance, what was our phasor diagram, sorry, circuit diagram? It was E naught. For generator I am drawing. In case of motor, what will happen? Here it will be V. Okay. So we can write the motor equation like, okay, let me write it in the, okay, let me write it here only. The motor equation is what? V is equal to E plus I R plus JXL, or is equal to E naught plus I R plus JXL plus JXAS. Correct. Now let us try to proceed in this way. First draw V as reference, then I. Now we need to subtract IR. So this is minus IR. Then minus JIXL. So this is our minus JXIL. is minus r. If you join, you will have E here, right? Now, if you further subtract, this is our E. If you further subtract minus jxias, then you will have what? E naught. Now, try to understand that uh, here. Now, see, this is our motor phasor diagram. Now, obviously, one thing that is very interesting here, don't get misguided. Can you tell me that position of your field, like what will be your armature field and all this? Here, actually, see, when I'm talking about pool, I would like to go back here in this diagram. See, basically, this person is causing at means it is leading this one. Now, what is the angle of lead? The angle of lead, if you try to calculate, you will find it is precisely 90 plus delta plus theta. Okay. In case of your generator, it was lagging, armature MMF was lagging behind your field MMF. If you are still not getting my point, with this we can try. This is your armature MMF, that is A. See the angle 90 plus delta plus theta. Now the armature MMF should lead, and that lead will be how much? That lead will be your, you can say it is 90, like what would be the angle? Let me first draw them, then you can figure it out. Again, we'll follow the same culture. From E, previously how we start drawing? We start it from E, right? Just let us draw it with a short phasor. Use a different color. Let us use, yeah. This is your means from E. Now E is our cos, and FR, the resultant field, if we say it is FR, that is that should lag E by an angle 90 degree. So let us draw FR. what about your means how can you find out if FR is what? FR is basically vector addition. Here you will have your A, right? So again FR is what? FR is F naught plus A. So if you apply the same logic and doing FR minus A will give you F naught. So if you do it by drawing minus A and join it, you will find F naught. Now see, here many things becomes apparently very clear to us. What are those things? Here I have assumed that my motor is drawing lagging current. Now see, if the motor is drawing lagging current, then it is just like that regulation scenario of your transformer, where it is sufficiently demagnetizing in your nature armature current. But here, in case of motor, one thing is different from that of transformer. In case of your transformer, current was flowing means outward, means from through secondary terminals. It was trying to flow from inside of the transformer to your load, and now in case of your motor, it is pointing towards your motor body, right? It is your motor is drawing current from outside. So if that is the case, now think about it. Okay, that means if you are not able even convinced with this logic, transformer and this that, think about you are having V. Then you subtract a lagging current. So lagging current will what will have here? Typically you will have so what you will get here, that is very interesting. If you proceed in this way, considering this minus sign due to lagging current, you will see that this whole thing will generate or will yield mod V is greater than mod E is greater than mod E naught. If you proceed, you will get this relation. Now, if I assume that V is at rated voltage, rated line voltage 415 volt, then by this one, if we have to ensure flow of current inward direction, E is magnitude of E is less than 405 volt and E naught is less than E. So if this 405 volt is motor rated voltage, then what we can conclude, in order to ensure motor is drawing lagging current, you must provide under excitation. What is that under excitation? Like if we assume linear circuit and consider that this FR is magnitude wise proportional to E and F naught is proportional to E naught, we have to conclude that this F naught is smaller than F rated. What is F rated? When F rated acted on the same machine working as a synchronous generator in open circuit condition gives you 415 volt line to line. Clear? So, under excited motor, draws lagging current. And if you try to extend this in case of your generator, you will find overexcited generator overexcited generator delivers lagging current. If you are not able to means catch my word, let me write it here very clearly. Now, just a minute. Now see what happened in case of like a motor that draws leading current. From that previous one, we can try to means understand this. Well, let me draw it first. Without means, let us keep it as a suspense and let us draw it. Let us see. I am not doing any manipulation. Just I am following means trying to draw a correct phasor diagram. A rough yet means reasonably correct phasor diagram. Now accordingly let us draw FR lagging E by an angle 90 degree. This side is A, so that will be minus A. So Well, just a minute. If R V S just a minute. Now for lagging load, everything will remain same. Like E naught will be V minus I cos theta plus J sin theta R plus JXL. So from this we need to, sorry, JXS, where XS is XAS plus XL. Now without doing much mathematics, let us try to draw the phasor diagram, a rough freehand phasor diagram with at least logical coherent with what we have discussed. So this is I. Now let us draw minus IR. What about your minus JXIXA? Let us just draw it quickly. Then minus JXAS. Now let us draw our E and our E naught and right. Now see, similarly we can draw FR, that is lagging E by an angle 90 degree. Draw FR 90 degree. Now minus A. Now join them to get F naught. Now see the magnitude. Clearly this diagram implies mod V is less than mod E is less than mod E naught, and therefore if you again keep V is equal to rated voltage, then E is already, obviously here we are assuming linear relationship. It is not the actual case. Obviously there will be saturation and you will not get a proportional rise in the voltage, induced voltage. But in case of overexcited synchronous machine, synchronous motor, that overexcited synchronous motor can draw your leading current. Overexcited synchronous motor draws leading current, right? And this overexcited synchronous motor is also known as synchronous condenser, and we use it for power factor correction. Right. Now, just like cylindrical rotor machine, we can draw it for synchronous salient pole also. This is for salient pole. Salient pole, let me write, otherwise we will get confused. V is equal to what? V is equal to, previously what was V? It was E naught is equal to E plus I, or from V it was I R plus JXL plus JIDXD plus JIQXQ, right? So basically it was current was flowing from, in case of generator, this is for generator, E to V, E naught to V, and also you are having E1, that was V plus I R plus JXQ, correct? And also you have only E, that was V plus IR plus JXL. Now in case of motor, what would happen? The direction of current will be V to E naught. So means from that current reversal we can write the same equation, like E naught would be V minus IR plus JXL minus JIDXD minus JIQXQ. So from this we can draw the phasor diagram of this motor also, like this is our V. Now suppose the motor is drawing lagging current. So lagging current means I will be lagging V by an angle theta. Like the previous case, here also we can first find out all these will be reversed. First find out E1 to generate the information about beta. So let me draw minus IR. This is my minus IR. Then let us draw minus JIQXQ. Now this is our E1. This angle is how much? Delta, and this angle is our beta. So we can have our two components of armature current. Along this, here it is our IQ, and basically it is like this. Now once we draw this, then we can draw the remaining part, like you can draw minus JIXL. So This is our E. Okay. Now we can draw JIQXQ, right? From this we can draw, or even we can draw minus JIDXD. So what about minus JIDXD? This minus JIDXD will be lagging this ID by an angle of 90 degree. So if you draw it, or let us start with this one also, then that would be a bit easier for us. It would be like something this. And then we can have this one, that is our E naught, right? So the resultant phasor will be like this. If you want to draw ID first and then IQ, that is also okay. You can draw it like first you have to draw minus JIDXD, that is lagging this one by an angle 90 degree, like almost this. So it will be like minus JIDXD. Then from that you have to draw minus JIQXQ to get E naught. So clearly, if you consider the magnitude of E naught, uh, so like the previous case, here also the machine is under excited and drawing lagging current in motoring mode. Right. Now also we can have the leading case. What about the leading case? Oh God. The leading case will be V I, then you are having your minus IR, now draw minus JIXQ, that will give you E1. Now this is your delta, this is your theta, this much is beta. So you can draw ID IQ. So what about your ID? This is your IQ. This is your ID. Now draw minus JID XD. So that well, sorry, here I have made a mistake that this one actually here either you need to consider, if you consider XL separately, XAD, XAQ, or just a minute, just a minute. Yeah, sorry, I just made a small mistake. Please correct yourself. Like either it should be like VIR plus JID XT JIQ XQ, or if you see, if you write JXL here, then you need to write XAD XAQ. Okay. Otherwise, all the other equations are correct. So only changes here we need to make, that from minus IR we have to draw this one like this line. This was our V. So from the tip of this E minus IR, we need to draw minus JIDXD. This JIDXD will be and from that okay, it should be from minus IR, not from the tip of minus IXL. This is minus IXL, that is for E, but otherwise when you need to connect, you should treat it from IR to this. Okay. So here also similarly what we will have, we will have our minus JIDXD. So minus JIDXD will be in this way. And then it is minus JIQXQ, and together you will get E naught. So mod E naught is greater than want V. So overexcited motor draws leading current, right? Overexcited salient pole motor draws leading current.